Assalamualaikum and hi. In this video, I will explain and verify our 4-bit arithmetic logic unit or ALU design using logic gates in quarters prime. The ALU perform for operation addition, subtraction, XOR, and XNOR. The ALU has two 4-bit input A and B and one 4-bit output which is Y. A 2-bit control signal select the operations. When we put here 00, it will perform addition. When we put 01, it performs subtraction. When we put 10, it performs XOR. And lastly, when we put 11, it will perform XNOR. The design consists of three main parts: the control logic, the arithmetic unit, and the logic unit with output selection. All parts are implemented using basic logic gates, making the circuit fully combinational. The arithmetic unit is implemented using a 4-bit ripple carry adder, where each bit uses full adder logic. For subtraction, the circuit applies the two complements method, which is the input B is conditionally inverted and an initial carry in is added. This allows the same adder hardware to perform both addition and subtraction. The carry signal propagates from the least significant bit to the most significant bit, forming a ripple carry structure. Then, XOR is generated directly from A and B, and XNOR is obtained by inverting the XOR output. The final output is selected using a gate level multiplexer. Enable signal ensure only the selected operation contribute to the output. The results are combined using AND and OR gates to produce the final output Y. So to verify, I will choose 4-bit for A and also 4-bit for B. So for A, I choose it 1010, which is equivalent to 5. And for the B, I choose 1100, which is equivalent to 3. So if we using 00, which is addition, so we done running, you can see here that the result is 1000, which is equivalent to 8. So for the first one, addition is true. So next, we will try the subtraction, which is we change the 00 to 01. So this is the result of the subtraction. As you can see, 5 minus 3, we should get 2 right here, 0010. So it's true. Next, we want to do the XOR operation, which is we will change this to 10. This is the result for the XOR function. As you know, in XOR, when the input is the same, it will produce output 0. When the input is different, it will produce output 1. So here, 1, 1 is the same, so it will produce 0. 0, 1 is different, it will produce 1. 1, 0 is also different, it produces 1. And 0, 0 is the same, so it will produce output 0. So now, last but not least, we will test the last function, which is the XNOR operations. So here is the result for the XNOR. As you know, XNOR is the complete opposite of the XOR, which is when the input is the same, it will produce 1, but when the input is different, it will produce 0. So here you can see the input is the same 1, 1, it will produce 1. When the input is different 0, 1, it will produce 0. When the input is 1, 0, also different, it will produce 0. And lastly, when the input is 0, 0, which is the same, it will produce 1. In conclusion, the simulation result verify that all 4 ALU operations function correctly based on the selected input. This completes the design and verification of the 4-bit ALU. That's all from me. Thank you so much. Bye bye. Assalamualaikum.